Assalamu alaikum. Hello everyone. This is Kamran Azim. I work at Pragma, a company in Oslo, as a consultant, and in my free time I make educational videos through my channel named WBITT. Today we are going to talk about LetsEncrypt, a basic setup, or first actually to understand how LetsEncrypt works. And I will explain that by using a simple web server. We will cover both HTTP and DNS challenges. And the idea of this video came up when I was working on some Kubernetes videos for the same topic, and I thought that before I release those, there should be some videos about LetsEncrypt in the first place. So here it is. So it's going to be a lecture style video. It's not going to be a regular 5-10 minutes video, so bear with me. So first of all, let's put this on the side. Very good. Okay, so I have two pieces of material for you. One is this presentation, and you will get the link in a moment. So this is the presentation, which contains some graphics which I'll show you, and then I have a repository, a GitHub repository, which contains all the material used in this video. So I'll be using these two, and this readme or this technical material would actually be used during the demo session, which will probably be second video. So let's start with the presentation. Yes, I have permanent bad throat, so you have to bear with me for that. So the link of this presentation is written in the README file in the GitHub repository. So it's you should have no problems accessing it. Right. So let's encrypt. So before we discuss let's encrypt, let's very briefly, in very layman terms, discuss what is HTTPS and why should we care. So most of the websites you visit nowadays, when you type in their URL or their name or DNS name or FQDN, you will see a padlock sign beside the website's name, and that gives you some sort of confidence, right? And that is true. This padlock indicates that this website has a secure encrypted connection between the site all the way to your computer, or to the browser actually. We know that internet is just collection of big bad it's a wild west. So it's represented as a red internet. So when you want to transfer some sensitive information like username, passwords, credit card information, etc., you don't want anyone to be sniffing on them, right? So there comes HTTPS, and HTTPS works with the help of something called SSL certificates. So these certificates allow the mathematics of this encryption to happen between your computer and the web server in this example. So HTTPS is Hypertext Transfer Protocol Secure. A very layman alternative name for it, just for the sake of understanding this whole concept, would be SSL, which is Secure Socket Layer, and a new name is also possible to be used interchangeably, as the word is TLS. Now I know as a person belonging to this domain that these three words mean separate things, but I'm not going to go into the technical detail here. This video is intended for for everyone, and I don't want to bombard with a lot of technical detail, unnecessary technical detail. This video is about LetsEncrypt. It's not about how HTTPS works. All right, so HTTPS is good, right? You don't want your website to be on plain HTTP, especially if it deals with sensitive information or sensitive data. So to establish HTTPS, or to have this facility to run your website on HTTPS, as I mentioned, you need certificates, right? Some SSL certificates, some special certificates. These are some special files, and for a very long time until now, the only way to do that was to actually contact someone called certificate authority or certificate provider or certificate sellers, and you would go and hand them a bunch of money and they would hand you back a certificate. So here you are giving them some money, and here they are giving you some certificate for your website, and it's expensive. So you take extreme care of your certificate, not because it's just it's expensive, but also because it represents an identity of your website. So it is supposed to be handled seriously. So you take that certificate, install that in the server, and then do certain other configuration in the server and restart your web server, and there you go, your website suddenly starts serving its content on HTTPS, the secure layer. So now your clients can use this encrypted or secure channel with your website and browse the website or whatever content you're serving, and they can also feel confident because this certificate has come from a certificate provider, from someone which is trusted by your browser, because the browser contains the browser contains signatures, or actually the CA certificates, a bundle of them, of well-known CAs in the world, certificate authorities. So the browser knows those certificate authorities, so any certificate issued by them is validated, is considered a valid certificate. But you should know that the other way to set up HTTPS is to just set up some self-signed SSL certificates, which are free. But the problem with self-signed certificates is that it's signed by you yourself and nobody trusts you. If I sign some certificates, nobody trusts me. So if I set a website with the self-signed certificates and ask people to do whatever the site offers, then people would be hesitant. People will not trust it because the certificate is not certified by anybody in the world. So naturally, the only way was to use certificate authorities. The problem was that certificate authorities had a monopoly. They were selling certificates, they were expensive, and since they were expensive, not everyone used them. So that means a lot of internet web servers are still insecure because they are just running on plain HTTP. They can't afford, or they couldn't afford, the certificates. So slowly this became more of a security problem than a money-making problem. So some people thought, okay, could it be, this could we solve this problem? Could we have something which doesn't need this money and still have certificates? So they thought it should be easy. What if there is some generous certificate provider who just issues certificates for free? Who would be crazy enough to do that and not make any money? So some people thought of this noble idea. So their idea was that it should be this much simple, that you ask someone, some special service provider, some certificate provider, and say, please give me a certificate, and they give you a certificate free of cost, and then you take that certificate, install it in your server, and enable your web server to start serving content on HTTPS. So this would be a trusted certificate. The browser would have the CA of this certificate provider in it, bundled inside it. So whenever it encounters any certificate issued by it, it would trust it. Now the question was, who would do it? So some people got together. They said, let's encrypt the internet for free. And their idea, as I discussed, was to lower the barrier to enter into, to enable HTTPS, to secure their web services. And the people who thought about this idea were Mozilla, EFF, which is Electronic Frontier Foundation, Akamai, University of Michigan, and Cisco. So they started working on this idea, and they had everything in setup eventually by September 2015. And at that time, they issued their very first SSL certificate for a domain, helloworld.letsencrypt.org, which was, of course, their own subdomain. And after doing certain more testing and making sure that everything is in place for this service to work, they launched a general availability in April 2016. Now, these certificates issued by LetsEncrypt are only valid for 90 days, and they need renewal every 90 days. So that you don't just get a certificate and just forget about it. So you are engaged in this process. And how they work is so this system was called LetsEncrypt, right? I forgot to mention that, but it's quite obvious. So LetsEncrypt has two certificate environments. One is called Staging, which issues test certificates, not production certificates. These certificates are invalid. They are certificates, they provide HTTPS functionality, but they are not trusted by any of the browsers in the world. So that's why they are invalid. The other certificate environment is production environment. You can also call them certificate servers, so to speak. So the other certificate server is production, which issues actual valid certificates which are trusted by the browsers in the world. The difference is that since it's a mechanism which people use automatically and not go through a certificate authority, not go through the complex process, so there are many possibilities where things can go wrong in these automated certificate generation processes. So that's why these two certificate environments, when you are setting up your HTTPS setup with LetsEncrypt for the first time, it's advised that you use the staging environment, because when errors occur, the staging environment is quite forgiving. They allow 60 failed attempts per hour. Whereas the production system allows only 5 failed attempts per hour. And if you do more failures during this allotted time, then you are blocked for a certain time. Right. So to validate your identity, that you are, who you claim to be, who you are, there are two types of challenges or validation mechanisms. One is HTTP 01 and the other is DNS 01. The 01 beside these two words is the version number of this challenge. If they improve it, they will name it probably HTTP 02 or something like that. So for individual websites, like individual URLs or DNS names or FQDNs, which is fully qualified domain names, you can use HTTP challenge. But if you want a wildcard certificate for your domain, for example asterisk.demo.wbit.com, then the only challenge which will work is DNS. Let's Encrypt supports 3 challenges: HTTP, DNS, and TLS ALPN, but the last one is not for everyone, so we'll just restrict our discussion for these 2. So a little more about Let's Encrypt. It was, as I mentioned, it has some initial supporters, so later on some more people joined it, like Linux Foundation, Stanford Law School, Eden Trust, which is itself a CA, CoreOS, etc. And what they did was they actually made a research group named Internet Security Research Group, and everything they did was done through this, this logical grouping, this ISRG. And ISRG in turn created 2 things. One is it created the certificate authority and the server-side software. So the certificate authority is Let's Encrypt, and the software used on the servers which issues these certificates and handles all this certificate requests and everything, that server-side software is Boulder, written in Go. The other thing they created was the Let's Encrypt client, which would talk to this server component, and that client they have written in Python, and its name is certbot. Right, so there are many other clients as well besides certbot. There are many, and those are being used on different web servers, as I have shown here. So suppose it's a web server, either Apache or Nginx, and it has some sort of Let's Encrypt client installed on it. How would it talk to the Let's Encrypt server, either staging or production? The way it talks to it is through something called ACME protocol, which is designed by Let's Encrypt. That's the way how certificate requests would be handled and how certificates would be issued. So ACME in older days, when I was a kid and watched cartoons, ACME used to stand for a company manufacturing everything. But in this particular scenario, it means automated certificate management environment. All right. So that's how the clients talk to Let's Encrypt servers. Very good. Now let's talk about how HTTP challenge works. How would you set up certificates? How this whole thing works? And that is what I've tried to cover in this diagram. It is a simple diagram, and just allow me to explain it. So the first thing is the internet, of course, and naturally the certificate authority Let's Encrypt is connected to the internet. That's understandable, and these are the 2 certificate environments or servers. One is staging and one is production, belonging to Let's Encrypt. The second most important item here is your web server, where you are serving some websites. They could be any websites. They could be, and they would be configured as virtual hosts in your web server's config file. In this example, the virtual hosts running on this web server are cat.demo.wbitt.com, dog.demo.wbitt.com, jumpbox.demo.wbitt.com, right? So this is a simple web server running some virtual hosts, serving some virtual hosts. All right, the fourth important thing here is the DNS server, where all the domain information of your web server or all the DNS names you are maintaining under that domain are recorded. And for any domain, for that matter, whatever you are managing is in some DNS server. So this web server is publicly accessible. It has a public IP address, as you can see here. This DNS server is also supposed to be public DNS server, publicly accessible, and it has here, for the sake of simplicity, I have a wildcard DNS entry *demo.wbit.com, which points to the public IP address of my web server, which is here, right? And then we have the site visitor or the user, right? Here the user is. All right. Now, you want your web server to serve all these three virtual hosts through HTTPS. So to do that, first of all, you have them running as HTTP, right? Simple HTTP. You're serving them over plain HTTP protocol, port 80. So that is established. You have your DNS running and it's set up correctly. You have your web server running on port 80. Then you install certbot, which works beside or works with the web server. And it is very important to highlight that for LetsEncrypt to work, either HTTP or DNS challenge, to get the certificates properly and not get locked out, you need to have your name resolution and web server connectivity configured correctly 100%. Otherwise, you will go through a lot of pain. All right, coming back to this diagram. So we have this certbot here, this one. It works with your web server as a sidekick or a sidecar, or it, as a helper. And it handles all the certificate management for the web server, because the web server themselves don't have this logic and this mechanism to do this kind of work. So you install this certbot on the web server and you start configuring your virtual host one by one to get to enable HTTPS. So for first virtual host, cat.demo.wbit.com, the certbot starts off with, or you actually initiate the command, but certbot sends a request for certificate all the way to the staging server. Now I've intentionally highlighted or connected all the lines to the staging server because that is how you should also think. You should always go for staging server when you are setting up your infrastructure for the first time. When everything is in order, then and only then you change the configuration to start talking to the production server. All right. So the first the request is sent to the certificate server asking for a certificate. The certificate server in turn sends a HTTP challenge all the way to certbot, that here is a challenge which you must fulfill in order to get the certificate. And that challenge is actually, it is simply asking the certbot to place a certain key or a token or a secret string under a specific location in your web server, and it has to be under the domain name or DNS name or FQDN or the host name of your virtual host. So inside that it should be under .wellknown/acme challenge /token, whatever the token is handed over to certbot. Right. So certbot goes in, and since it runs as with admin privileges as root privileges, it goes and modifies, creates this file under this specific directory structure and informs certificate server that I have completed the challenge. Now you can validate it. So the certificate server then tries to resolve the name for which the certificate is requested, and that name is cat.demo.wbit.com, and it resolves that using the DNS. So through this this description here, you can see that if I try to resolve cat.demo.wbit.com, it will eventually resolve to 2.3.4.5, which is this server. That means this this certificate server will come to this web server on port 80 and will try to get this file. It will try to pull this file. Once it is successful in doing that, the challenge is validated. And on step number 5, the certificate server issues the certificate to certbot. And this is that certificate, cat.wbit.com. And certbot, as soon as it receives the certificate, it does 2 extra things, only if it is running beside Apache or Nginx. Those 2 things are that it will modify the virtual host configuration for this virtual host and will make certain SSL related configuration adjustments, and will also restart the Apache or Nginx web server. So now when you access it from wherever in the world, for example from here, if you do curl or do a browser connection here on port 443 using cat.demo.wbit.com, then you will see an HTTPS connection, although it will not be valid because it is a staging certificate which is supposed to be invalid. Now remember the HTTP challenge. The certificate server tried to contact on port 80, tried to contact the web server on port 80 to get the token which it asked certbot to place. And that is because it assumes that the web server doesn't yet have HTTPS mechanism, so it will not try to contact on HTTPS. That's the idea of getting a certificate from the certificate server in the first place, right? Because we don't have the HTTPS mechanism. All right. So this is important to understand. This actually means that when you're setting up your web server, you should make sure that any perimeter or network firewalls allow incoming port 80 and port 443, right? Any incoming traffic for port 80 and port 443. And on the web server itself, any host firewalls like IP tables should allow incoming traffic for port 80 and 443. It is important the way HTTP challenge works. That's important. All right. So when this is done, then either you can go on with the second virtual host and set up certificate for that, or then you just ask certbot to start talking to the production certificate server, and the same process goes on, and this time you get a production server production certificate which certbot places in the web server somewhere in a special directory. And that is where I mentioned that it makes certain adjustments. That is part of those adjustments. It places the received certificate in a certain directory. That directory is somewhere in /etc/LetsEncrypt/ domain name, whatever the domain name, /live/ etc. etc. And I'll show you probably in a moment or in the next video. So this is HTTP challenge, right? The main emphasis was that the challenge is supposed to be validated or verified by the web server itself. Now let's talk about DNS challenge. So DNS challenge is particularly important when you want to obtain wildcard SSL certificates. and how it works. So let's say you have the same three hosts, cat, dog, and jumpbox.demo.wbitt.com, but instead of having single or individual SSL certificates, what you want is a wildcard certificate. So you've already ensured that your DNS is in order, your web server allows incoming traffic for port 80 and 443. You initiate the certbot certificate process, and the first thing it does is request for certificate to the certificate authority, the staging server at LetsEncrypt. And the staging server, seeing that this is a wildcard certificate request, it asks for a DNS challenge to be fulfilled, and it gives the challenge to certbot. So certbot receives the challenge, and since it's a DNS challenge, certbot then goes in to the DNS server and tries to fulfill the challenge. What is the challenge? The certificate server gives it a string and asks it to write it as a txt record in the related domain DNS zone file. So, and the txt record should look like _acme dot whatever your domain name, which is demo.wbitt.com. It should be a text record, and it should contain that secret which the certificate server has given to certbot. So certbot goes in, writes this new entry in the DNS server, and I'll come to it that how it does that, and informs the certificate server that I have completed the challenge, please verify. So DNS server goes, certificate server then simply tries to dig the txt record, tries to get or pull this txt record from the domain zone information by just using any DNS in the world. It doesn't necessarily has to talk to this particular DNS server. So it just pulls that information and tries to get the txt record or the text record. And when it gets it and sees that the secret mentioned in the text record matches the secret which I gave to certbot, then it means that this server claims who this server is. This server is who this server claims, and hands over the SSL certificate here, right? Hands it over to certbot, which in turn goes in the file system and places it under a certain directory. But this time it does not do the two extra steps. It does not modify the Apache or Nginx virtual host or SSL configurations, and it does not restart the web server. This is a limitation with the DNS plugin, right? So the question that how certbot writes or creates this record in DNS, that happens by providing extra information to certbot, and that extra information is the credentials of the DNS server. So in my case, demo.wbitt.com is actually hosted on AWS Route 53, and I have created a low privileged IAM user to manage the Route 53 or the domains or the zones I have. So I have provided the AWS access key ID and the secret key to certbot for this zone, for this account. And whenever certbot receives a DNS challenge, it uses those two pieces of information and logs into my Route 53 interface or talks to it programmatically through API and creates and removes DNS records as asked by the certificate server at LetsEncrypt. So as soon as the DNS challenge is validated and certificate server says you're good, so certbot removes that entry from DNS. That's why I say it creates and removes. So when the certificate is arrived, then what you do is, and here is that certificate by the way. So when the certificate arrives, certbot places it somewhere, but you as an administrator would need to modify the Apache or Nginx configurations yourself to place in, to adjust the name of the certificate files and key files and some redirects and whatnot, and restart the server. And then this user or this visitor of your website would type in the name like cat.demo.wbitt.com in the browser and would have an encrypted secure connection with your server. Since it's a staging certificate, the browser would not trust the certificate, but would still be an HTTPS or encrypted connection. Now when everything is in order and you see everything is working correctly, then what you do is you talk to the production certificate server instead of staging and go through the same steps, and then you will have production certificate which will be trusted by the browsers. So this was how HTTP and DNS challenges work for LetsEncrypt. Right, so that was HTTP and DNS challenge. A little about TLS ALPN challenge. So this is basically, the first thing I want to highlight is this challenge is not suitable for most people as written on LetsEncrypt's website, and the reason is that this challenge is a special challenge. Only the large hosting providers are using it at the moment. Most of your use cases will be served by HTTP or DNS challenges. Right, so next comes the demo of all of this, what I described, and we will do that in a moment. But I want to thank you for your time and see you in the next video. Right? Okay, assalamu alaikum.